2.
Try again. Try again. Um, so f of -3 means parentheses -3 squared minus 4. So you have to multiply -3 by itself and then subtract 4. You're not multiplying it by 2, you're multiplying it by itself.
3.
-3 times -3.
9.
9. 9 minus 4 is
5.
5. Okay, so we've done a bunch of these now, a couple in a row. There's some sort of disconnect. What do you think it is? Because I don't know how else to say it other than it's multiplied by itself, but I want to hear your side of it. It's like, why, how can we make this clear that you're multiplying those numbers together?
Because it's squared, so you're multiplying it by itself.
Yes, yes. Right. So it was when I asked you for f of 3, it's 3 times itself. 3 times 3. Then you subtract 4. What does that become?
5.
5. Good. Okay. Now we go back to the table and we fill in our table, 5 and 5. Are you surprised by that? Are you surprised that it's exact same value?
No.
No, you shouldn't be, because the vertex provides this point of symmetry. And there's symmetry in like everything. When you're driving, a car, cars are symmetrical, sports fields are symmetrical. Basically, there's symmetries all around us. And everything in a quadratic is symmetric about the vertex. So that final point is -4. So I'm gonna graph this here for you. 0 minus 4, -1 minus 3, -1 minus 3. Notice that those points are kind of right across from each other. Okay. And then when we graph 2, 0, -2, 0, and then 3, 5, -3, 5, something like that. Do you feel comfortable graphing something like this?
If I could get the points right.
That's the best way to say it. If I can get the points, yeah, I can graph it. All right, so since I heard a little uncertainty, we'll definitely do another one like this, but let's keep going with this particular problem here. The next thing that it asks for is the coordinates of the x-intercept. So let me snip that in. There it is. Okay. What are the coordinates of the x-intercepts of the function? Any idea what it's referring to when it says x-intercepts?
Where the absolute value meets the x-axis.
So intercept means like crossing, like where it crosses or touches. Have you heard of that before from class, maybe? Okay. So there's like two approaches to think about how to do this. One is to look at the graph. So if we go back up to the graph, where does it cross the x-axis? What are the two places that it crosses the x-axis?
-2 and 2.
Exactly. So there's kind of like, you have to decide, am I going to look at this graphically? Which is totally okay. It's -2, 0 and 2, 0. Or am I going to do it algebraically? Okay. And either way is okay. And this is the kind of question to ask your teachers, like, hey, I was working on this problem and I noticed that there are two ways to do it. I can just look at the graph, or I can do some other things. Like, is it okay if I just look at the graph? All right. To do it algebraically, you're setting the whole thing equal to 0. Okay. Now from earlier in the course, do you remember how to solve something like this? There's a couple of approaches that might work.
Add 4 to both sides.
Okay. X squared equals 4. From here, you're going to take a square root. When you take a square root, though, it's plus or minus the square root. So plus or minus square root of 4, x equals plus or minus 2. And we should not be surprised by that because 2 and -2 are over here in the table.
Mm. And then would you do the opposite?
What do you mean by opposite? Give me more information. What do you mean by that?
Like do a negative because then you'd get the -2? Like make
Exactly.
the
Yeah.
full.
It's 2 and -2, and the y value is 0 for both. Okay. So for x-intercepts, you have to decide, like I said, you're either going to do it graphically or algebraically. If you do it algebraically, you're setting the function equation equal to 0. Okay. Now we're going to look at the next part here, which is the y-intercept. And it's similar in the sense that you can do either a graphical or an algebraic approach. What do you think it means graphically, the y-intercept?
Where it meets the y-axis.
Exactly. Yeah, said really well. It's where it crosses or touches the y-axis. So where does it cross or touch the y-axis?
-4.
-4. Now it does say the word coordinates. Really means ordered
-4,
pairs.
0. Or at 0, -4.
Yes. Okay. So we're done, right? But you can also do this algebraically. And this time it means to set x equal to 0, put 0 in for x. And we actually already did that. 0 squared minus 4. What does that become?
-4.
Yes. And we shouldn't be surprised. We say, oh, well, that's what we expected because there's -4. What do you think about either of these things here? Is it better to do it graphically, algebraically? What do you think?
I think graphically is easier, but algebraically isn't that hard.
Do you think your teacher will say the following? You must know both.
I don't know.
Okay. So that's a good question. It's like, hey, can we do it one way or the other? It's a fair question to ask. All right, next part of this problem is to give domain and range in set builder notation. Do you remember anything about set builder notation?
X bar X ER comma and then like that's for the domain this well I forgot what the thing is called. Um
Don't worry about the
the
names.
bracket that goes around it.
They're curly braces, but on the left, you said it right. It's all real numbers. Okay, so until otherwise stated, just give your domain as all real numbers. But the range is not all real numbers. Do you remember the two possibilities for range when you're looking at a quadratic that opens up or maybe opens down?
Are we talking about like maximum or minimum?
Exactly. Yeah. If it has a max, it's y less than or equal to. And if it's a min, it's y greater than or equal to. Is that what you're referring to? Because that is correct if it is.
Mm-hmm.
Okay. So let's go back and look. What is, well, does this have a max or a min at the vertex?
Max?
At the vertex, at the vertex. Like, have you ever been hiking in Tucson?
No.
No hiking. Okay. You've been other parts of the country though?
Different
Or
states,
Tucson?
yeah.
Different states. Okay. Well, sometimes this is, to me, this is a valley. This is like, if I'm right here, I'm in a valley, it's higher around me. Whereas whereas the other way is like a peak. It's like, okay, I'm at the top and then up and down on either side. And hiking is a good example if you've done that. If not, it's okay. You can still imagine a valley versus a peak. So the valley is a min. It's the lowest point. The peak is a max. So we can
Oh,
even say the max. And then on the left here, this is a min. Okay. And keep in mind here, we're practicing for your final. So it's okay that you don't get it right first try. Your graph has a min. So it's y greater than or equal to -4 because that is the smallest y value. Smallest y value occurs at the vertex. So in this case, it's y such that y is an element of the real numbers, comma, y greater than or equal to -4. And then you put the curly braces around it. Okay, so I want to give you some more quadratics because I don't think this is clear at all. And that's okay, but that's the whole point of this. So I'm going to graph some for you here. And let's say this is a vertex of -5, comma 2. Is the range, well, let's see if you can help me out here. Is the range a less than or equal to, or is it a greater than or equal to?
less than or equal to -5.
So the range only refers to the y value. So you actually can exclude the x value altogether.
Yeah.
So you can just ignore it. So just 2 this time. How about this one over here? What's the range?
Y is greater than or equal to -3.
Good. Very good. Okay. So let me put a new problem in front of you. And I want you to, on your paper there, write the domain and range as soon as I get the problem put in front of you. Okay. Could you write down the domain and range, and then I'll do the same, and we'll see if we got the same results.
Um, would it be x is greater than or equal to 0 and y is greater than or equal to 1?
Okay, so the y is correct. Okay. Now here's what you said. You said x greater than or equal to 0. So what you're saying is x can only be positive. But what about a point over here? This point -2, comma 5. What's the x value there?
Negative.
Negative. So that's
So
out.
it's, so it's just all.
It's all until we talk about exceptions. Like one way to look at math is like this 80-20 rule. Have you ever heard of that?
Mm-mm.
Okay, so 80-20 rule refers to a lot of things in life, which we don't have to get into for this lesson, but there's like 80% of the things you need to know are going to be without exception, and then 20% are the exceptions. So in this part of the course, just think of x as being all real numbers until otherwise, until we say, okay, here's an exception. It's kind of like your default.
Okay.
All right, let's try another one here. Um, Actually, let's transition to the next topic here. So let's look at Let's look at a horizontal line and then a vertical line. So let's look at y equals 2. This is y equals 2. And then let's do the same thing for a vertical line. Let's go, do you have a negative number in mind?
X equals -6.
Okay, good. Like that, that worked. So x equals -6. Okay. So one of the ways that I always remembered horizontal lines versus vertical lines is I always think of it as y is always 2. Y is always 2. Anywhere along here, y is 2. Okay. Same thing for x. X is always -6. Y can be anything. Some people just remember the horizontal lines go out into the horizon, so they must go this direction. Some associate them with y. There's a lot of ways to remember them, right?
Mm.
But besides being able to distinguish between them, you have to be able to write the domain and range. Okay, so I'm going to write the domain and range for each of these because I don't want you to uh, make a false judgment of these. So for the domain of the first one, it's all real numbers. For the range, it's y equals 2. Okay, for the second one here, the range is all real numbers. The domain is x equals -6. Could you attempt to just study these and tell me how to sort of create a rule for this, or like how you might remember this if you're trying to explain it to someone else?
For the horizontal or vertical?
Or yeah, either one. Like how would you explain this to someone?
Uh, um, I don't know.
So what I'm also kind of asking here is like when you look at the two domains and the two ranges, do you see any similarities or do you see anything that you could use to try and remember them?
When you have a vertical line, the range could always be all, but the domain will be one number
Good.
because that's where it falls on the x-axis, and the opposite for a horizontal line.
Exactly. I like that last part the most that you said. It opposite. What I one thing that makes it easy to remember something is you remember one case and then the other is kind of the flip of it. See how the domain range is sort of flipped in each one,
Mm-hmm.
sort of. Um, you said it really well. All right. So I'm going to give you a practice problem here. Do you have any other questions before we do that one? Do a practice
Mm-mm.
problem? Okay. All right. So let me do this. All right. Given the Give the domain and range of the horizontal line graph below. What is the slope of the line below?
Um, Domain is all, and the range is um 2. Y equals 2.
Yep. That's also the equation of the line, right? Y equals 2.
Mm-hmm.
Now, do you remember the slope of a horizontal line?
It doesn't have a slope.
All right. Let's look at this a little bit closer here because there's two that you have to remember. Slope of a vertical line as well. So horizontal line, just like vertical line, you're looking at rise over run. Okay, so to go from this first point to the second point, how much up or down are you going?
Neither.
Okay, and how much are you running? Or how many? How many to the right are you going?
5.
5. Okay. Now, oftentimes division is forgotten as a sharing problem. Division is really sharing. It's how much you have to share, which is nothing, and how many people you have to share it with. I've got nothing to share but 5 people to share with, which is a bad situation in itself. But how much can you give each person if you have nothing to share?
Nothing.
Nothing. So you have to be careful with what nothing means. In this case, it's 0. So horizontal line, slope of 0. Now let's look at a vertical line. Let's look at the one that you mentioned earlier here. Give you a couple of points here. Let's say it's -6, -3, -6, +4. Let's do the rise over run thing again here. How much is it going up?
0. Wait, sorry.
You're just counting. Don't try not to overthink it. I mean, you're going up 3 to get back and then up 4 to get to the point there.
7.
Okay. And how much are you running?
None.
None. So you've been told forever, right? Division by 0, you can't do that. Well, why? Well, if you go back to the context I provided, it's you have 7 things to share, but no one to share it with. That's a really weird situation. But the mathematical definition or word is undefined. So a vertical line has slope that is undefined. Or sometimes you can say the word no slope. But it's not the same as 0. 0 slope is for a horizontal line.
Oh. So if it's vertical, then we can say undefined or no slope.
That's right. That's right. And so I had a teacher, a long time ago. Way he described it to me, it's kind of always amazing what is you will remember. Let's say you were standing on top of this vertical line and you fell off. What would you say potentially? Besides, let's keep it clean.
What do you mean by that?
Oh no. So that somehow maybe is a way to remember this. You've got to find a way to remember it because it's not intuitive. Like, why does left mean left and right mean right? That's sort of rhetorical, but I'm not sure, why is north up and south down? So we create these conventions and it's kind of up to us to decide if we want to, adhere to them and remember them. So I'm just suggesting somehow you've got to come up with a way to remember this.
Mm-hmm.
And I'll leave that up to you how you decide to do that.
Okay.
Okay, new problem here. We're going to redo some stuff here. I want the domain and the range of this, please.
The domain is all and the range is y is greater than or equal to -1.
Really good. Okay. Let me grab another question here for you. All right, so one more here. Can you give me the domain and the range, please, for this one?
Domain is x is equal to 3 and the range is all.
Very good. Awesome. Okay, doing great. Let's keep going here. You're my reader, right? You really like to read.
Yeah.
Are you reading anything good right now?
No, I was gonna go to the library tomorrow because I finished my books that I own, and I was gonna go to the library with my friends during lunch tomorrow to get one.
Get some new ones. Cool. Are you still kind of, I think you might have mentioned you're reading like a book a week. Does that sound about right?
Yeah, sometimes it's a little over a week depending on how much homework I have.
That's awesome. It's hard to explain to people how important reading is until they start doing it, and it's just amazing. You know, it should be like math. You know, we should all should have a good, solid. Okay, these are things I like to read. Good, solid math background. Maybe not algebra, but math, number sense, fluency, things like
Mhm.
that. Okay, so we were talking earlier about functions, and we're talking a little bit about making a table here. I'm going to give you the vertex, and we're going to choose two values smaller and two values larger. Okay. Now, when you graph something like this, you start with the vertex. You want to know that middle point. Okay. And I'm telling you it's at 2. We can talk about why that is another time. You have to calculate the output here, but you don't have to do it for every one, because if you recall, if we go back and look at this previous problem here, there was some
Mhm.
symmetry, right? Like that was the same as that, that was the same as that, and
Mhm.
so on. Okay. So that vertex creates that point of symmetry for you. So in this problem here, you do not have to calculate 0, 1, 3, and 4. You can do either 3 or 1 or 4 or 0. Okay, so I'd like you to calculate these values in here. And just pick one, do one, let me know what you come up with so I can check, see how that's going. And if you
Would
have
I
questions,
subtract it by 5 or 4?
well, you're putting these numbers in wherever you see an X. You're going to substitute them in 2 places.
Um.
Okay, so that made let's do 1. So f of 1 means 1 squared minus 4 times 1 minus 5. These ones were formerly x's.
Um,
They're now 1. 1 has taken the place of x. So now this is an order of operations problem. This is now, okay, I got to square, I got to multiply, then I can subtract and subtract. Is this totally foreign to you? Is this like reading a book in Chinese, or is this okay?
um, kind of new.
Okay, let's go through it together. What is 1 squared? What does that become?
1,
Okay, what is 4 times 1?
4.
Okay, so now it's just 1 minus 4 minus 5. You have to choose how you want to calculate this. Meaning like either you subtract left to right, or maybe do these two first. It's up to you.
Would it be -2?
1 minus 4 is minus 3. Minus 5, you bring that down. So it's like you owe $3 in library fees, and then you owe $5 more in library fees. How much do you owe now?
Like 7?
-8. -8.
Or, ah.
Okay. So that is supposed to be the same as 3. So let's have you calculate that next. F of 3 equals, now you're putting 3 wherever you see an X. So 3 squared minus 4 times 3 minus 5. You're putting 3 in for X. Okay, so just like we did before, can you try your best to calculate this for us?
-7?
Okay, let me check here. That sounds pretty good. 9 minus 12 minus 5. 9 minus 12 is minus 3. Minus 5 is minus 8. Where do you think you went? You went different than me.
I added 2.5.
Okay, so 9 minus 12.
Yeah.
Right. Okay, so now should that be a surprise? Are you surprised that these two have the same output?
No.
No. Okay, so let's do the same thing for 0 and 4. All right, let's do f of 0. F of 0 is 0 squared minus 4 times 0 minus 5. What does that become?
0 minus 5. Well, just negative 5.
Negative 5. Good. Yeah. Now I want you to do the same thing for 4. I want you to evaluate this function at the top here for 4. Put 4 in for x.
Negative 5.
Is negative 5. The reason we do this is eventually you say, okay, I'm not going to keep doing the same calculation because I know it's going to be the same. I don't have to keep doing something that I already know the output. But at 2, the vertex, you don't know the output. You have to actually do that. You'd put 2 in for x. All right, so go ahead and try that for us, please.
Negative 9.
Good, really good. Okay, so we next want to make a really quick sketch of this. And when I say quick, I don't want you to worry about increments. I just want you to sort of put the dots roughly where they go on your paper. So will you take a moment? It doesn't have to be to scale either, just roughly the right shape.
It's like going downwards and it has a maximum.
So you just described something to me like this. Is that what your graph looks like?
Yeah.
Okay, so maybe just a refresher on graphing here. 0 minus 5 would be maybe there. 1 minus 8 would be there. 2 minus 9 might be there. And then 3 minus 8 and 4 minus 5. So I'm seeing something that looks more like this.
Mm.
What do you think the differences between ours is like? How, give me more information or tell me what, if this is,
I did like different points.
okay, maybe you switch the order. It's got to be X before Y, right? X comes before Y in the alphabet. You know, you read the first page before the second in the book. Hopefully you're not one of those that flips to the end to see what happens. I'm kidding. That's okay. So I know some people do that. All right. So this has a minimum. Has a minimum 2 comma minus 9. Can you give me the domain and the range for this, please?
Domain is all and range is y is greater than or equal to negative 9.
Good. Yeah, really good. I like that. All right, so let's do one more function because I think this is needed to really solidify this. Let's go f of x equals 1 minus x squared. And again, I want you to fill out this table as best you can. But keep in mind, you don't have to try all the x values. You can try just the ones you like the positive ones and 0. You don't have to do -1 and -2. But what I'm looking for is for you to try some values in this function and report back what your y value is. Basically putting these values in for x. Let me know what you come up with.
I don't think I did it right, but like
Okay, which value
negative
did you start? Which value did you start with?
2.
2. Okay, so 2 is 1 minus parentheses 2 squared. So notice the number that you're substituting for has to go in parentheses. Really important to do that. That way you don't
Mhm.
mess with signs. What is 2 squared?
4.
1 minus 4 is -3. Is that what you have?
-2. Yeah.
Okay, and by symmetry, that's this one up here as well.
Yeah. And then for -1, I got 0. For 0, I got -1. And for 1, I got 0.
Okay, let's look at 0. 1 minus 0 squared. 1 minus 0. You said -1. It's you have $1 and no change. Subtracting 0 means no change, no difference. So just 1. Just 1. Is that okay? Clear? Maybe?
Mhm.
Okay. All right, could you make a quick sketch of this again this time?
Does it like go up?
You're plotting these points, hopefully, right? -2, -3.
Mhm.
So that means left 2, down 3, left 1.
Mhm.
Stay there. Okay.
Like it's on the left side and it has a minimum?
So again, so let me plot the points here and see if we're in sync here. So -2, -3, somewhere down there. Okay. -1, 0 is there. 0, 1 is there. 1, 0 is there. 2, -3 is there. This is the graph that I'm seeing when you connect the points.
Mhm. I keep getting I keep getting maximum and minimum mixed up.
Yeah, like I would think of like if you're standing here, are you king of the mountain?
Yeah.
Is that's when you're king of the mountain, you can see everything. If you like Titanic, whatever Caprio says at the he's on the ship. There's these like moments where you got to visualize what that means. I'm at the top, I'm the highest, I'm the max.
Mm-hmm.
And then the other way is, wow, that's gonna be a tough climb from the bottom. Okay, real quick here again. What is the domain and range?
The domain is all, and then the range is y is less than or equal to 1, negative 1.
Yes. Well, 1 or -1, which one is it?
1.
1, good. Okay, very good. The last question here, this is kind of one of those working backwards things. Let's say I tell you that the domain is x such that x is an element of the real numbers, x equals 1, and the range is all real numbers. Is this a horizontal or a vertical line?
Both are. Oh wait. Vertical.
It's a
What?
vertical.
Yeah.
So you could even graph this, right? You could say, okay, that's x equals 1.
I did. That's.
So it's actually vertical. Okay. So these are really hard to remember. It's like going back and forth, back and forth, back and forth, back and forth. Like, what's the right rule? I don't have a good understanding of how memory works. I can only tell you that you do have the capability of doing this.